Yeah, the cost stays that here. So when we come to costs, right, we are given a certain instruction, which let me share the instruction slide here so that we can look at it. We are given this instruction slide, which is as follows. So we're given this instruction slide. Here on the instruction slide, it says that if we have an absolute, which means a constant, right, n, this constant is gonna be counted as 1, right? The cost is gonna be 1. The cost that will be added on the constant is 1. Can be a constant or a variable. Like here, we have a constant, a variable. You see this, né? These are absolute. So when we have such a case, we're going to add 1. Now, when we have a register we don't add anything. You see that for a register, it's 0. Then when we have a constant times a register, we add 1. Then when we have a static register, we have 0. When we have a static constant register, we have 1. As long as there's a constant register there, right, it's gonna be 1. Then when we have a hashtag a constant, this is gonna be 1 also. So now if we come to this, now all these that they're right, we're gonna be doing this first, then we check how do we apply this. So let's check. Here's what the rule says. The rule says that these instructions, they have a cost added to them, which is 1. These instructions, these ones, you see right now. So if this already is 1, I must check if I have anything there that can add to the cost, right? Like for example, we look at the first line. First line already we have a load, which is 1, register is 0. Then we have y, which that is an absolute is 1. Then this will be 2, right? Then we come to the next line. We have load, which is 1, plus register, which is 0, plus z, which is 1. We have 2 there. Then when we come to this one, we have add, which is 1. We have a register 0, which is 0, register 0 again, which is 0, register 1, which is 0. Then the cost here is 1. You see that? Then when we come to this one, store is 1, x is 1, then register is 0, then that is 2. So when we add the cost there, it's gonna be 7. I'm sure we do get this right. So if you have any question, you can ask based on the first part. Then if not, yeah. So now what we can do from here, we see that we come to the next part right now. Let's come to the next part and see if we are going to get the same idea behind this. So we come to the next one. The next question, it says that we have load. And remember, they just took these questions, they're all here, right? I took this one. I think it's the one which I took here from the exam here. It's number 1 and number 2. Started by number 1 and number 2, and then I added some questions there. So number 2, we look at this. We have load, which is 1. We have register, which is 0. We have I, which is 1. That's an absolute, is that right? And then we have multiple, which is 1. If you check, that one is 2, right? It was supposed to be 2 plus 2 plus 2 plus 2, which is 8. Let's confirm that. This is 0. This is 0. This is 1. And then we have load, which is 1, R1, which is 0. And then this, I said that if there's a constant in a register, it's going to be 1. I said right now. And this is supposed to be 2, which is 2, right? This is 2. Then we have a store, which is 1. We have B, which is 1. We have R, which is 0. And this is 2. If we check this, this is 8. The cost for this one, it's 8. Then, now we come to this one, the last part, right? On the last part, they say that this one, let's say that we're given these instructions. The same thing, load P, this is 2. Load constant and register 2. Load X 2, this is gonna be 6. You see right now. And then this one again, load P, load X, load this 2 to 2 is 6. You see right? The same thing. So do we say that registers are simple, right? Using registers, simple. And also calculating the cost. When I was busy doing this thing, this one was visible. I don't know what happened here. So now let's come to these ones. Not these ones you'll do them in second semester, but yeah, you'll do this in assembly language. Let's check this one. Yeah, we need to start from here. I think it's, yeah, we can start with the first one. This one, we are generating a code for basic arguments or assignments. So now with this one, let's say we're given x equals 1, right? When you're given that x is equals 1, first thing that you need to do, you need to load this one into a certain register. So we load 1 into a register. That's right. So here we're saying we are loading 1 into a register. In other words, R1 is equals to 1. Now after loading this, we must store it into X. We store register 1 into X. That's why X comes first now. You see right now. So this equal sign will be representing store. So now we check the second one. We do the same thing. We load A into a register. First, we must load this thing into a register. We load A into a register, meaning that R1 is equal to A. Then we store R1 into X. We always read it like this, with this into this, this into this, add this into this. So like that. Now we have this now. You see now the expression is expanding, right? Now we have two coefficients there, or two expressions within that thing, because yeah. So now we have x is equal to a plus 1. We have to load this, right, into a certain register. Then we can add it like that. So when you're adding, let's say like this, I'm trying to, this is a minimized code, right? Someone would say this, would say I'm loading into R1. I would load, or let's say into R0, right? I'll load A, or maybe let's start with R1. Let's use R1. I would load A into R1. In other words, R1 now would be equals to A, right? Then I would load into R2 1. I said that in other words, R2 would be equals to 1. Then I would add this 2. Then I must store it somewhere, so I'm going to store this into R1. So the first register, we are saying that we are storing this addition of these two things into a certain register. So I'm going to store this into R1. So I'm saying that, yeah, I'm going to add the contents of R1 with the contents of R2. You see right now, let's add this into this. We're adding R2 into R1. Then I store the results in R1. Then I store the results of R1 into X. Remember, this is saying is equal to X. I store the results of R1 into X. So we can minimize this. You see right? We can minimize this to come and say, I'm removing this. When I remove this, remember, 1 was stored in what? Was stored in R2. It means that now 1 will be independent of any register. So I put 1 there. You see now why this one is like this, right? So this is a minimized code. You'll learn more how to minimize codes on still on SCOA021. You'll learn how to minimize code. Then we come to this one. Now let's come to this one. Let me check if I think I have another. Let me check. I think I have another. Let me check if I have another example that we can look at here. Let me see if I can look at another example here. Yeah, I have this. Will I write this? Yeah, also another one here. It's here, right? Number 4. We can also do this one. For it's saying x is equals to a plus b. So remember I said that you can do this, right? You can load into R1 A and load into R2 B, then you add them, right? But you're gonna store this in R1. Then I'm adding the contents of R2 into R1. You see, right? Then I store into X R1. I'm storing this one. So this one cannot be minimized to this. We can only minimize it like this if it's a constant. If this one was a constant, or one of it was a constant. You see, right? Now this one is not a constant, so we can't minimize it to this. So that's why I had to write this one so that you can see. All right, ne? So now we can also have another one to say that let's assume that we're given 2 statements. Let's say we're given 2 statements. Those statements are, let's say, let me write 2 statements here. Let's say we're given, let's say we're given 2 statements. Can be given what? Let's say you're given that x is equals to let's see that y is equals to a plus x. Yeah, so here's what we're gonna be doing. Let's start with this one, right? The first one. Then we apply for the first one. So first I'm gonna have to load into R1. I load B. You see, right? So I'm going to have to load into R1B. Then I load into R2C. I've loaded these 2. You see, right? Then I come to multiply. Then I multiply. You remember that is a star there, so it's for multiply. I multiply. I store this in R1. I multiply into R1, R2. So I'm taking R2 multiplied with R1. Remember, according to this, they're like this, right? R1 came first, R2 came second. So even here, you must keep the syntax. That's what we're doing also here. You see, right? R1 came first, this one came second. So now we are done multiplying this. So we can now load the other contents. Remember, this is X, right? And we know that X is stored in R1. So now we load the contents of A. We load the contents of A into, we can maybe load it in R3 because we haven't used R3, right? Then now we can add. So check between R3, remember now X is R1, right? Between R3 and R1, R3 is the one that came first. So here we're going to have what? We're going to store this in R3. We're going to store this in R3. Then we add R3 with R1. Then we store this in Y. We store the contents of this R3 into Y. We say that, then that's how it's going to be. Or simply, you can just, you see this equation, you can just say y is equals to A plus B star C. So in other words, I just substituted this there. But make sure that you always start with the ones that came first. But according to BODMAS, we are supposed to start with this. So I mean, if this was down here, make sure, I think the best way we can look at this is if we can use BODMAS. So that's where we can all arrive at the same solution. So if we use BODMAS, we'll be fine. So yeah, and if you have any question here, you can say it, because I can't see this. I can see what's this, the comment section, right? You can see the comment section. So now we come to this. Now here, what we have is that they say we are given these statements, right? We are given these sequences. So these sequences can be given to us like this. They can write them like this. They say X. I think these ones, they didn't bring them in an exam, right? So they're gonna be there in the supplementary. Y is also says that because of space I had to write them like this, right? And given that I'm using code to write this, so it gets difficult when I'm not writing them like this. So Y, we have B, then we have J here, we have X. So now we want to remember this code is for that, right? Now for us to compute this, we can't compute this if we don't know the arrays value, right? These arrays, we're saying that this, remember these are what? These are the 3 address statements. And we must know that these A and B are arrays or whose elements are 4 value, right? Or 4 byte values. So you must know whether this is a 4 byte value, 8 byte value, so on, so that you can know which value to put here. So now let's start it and say, first, what we do here, remember we always have to load something this side, right? We always have to load something, even here, we always have to load something. So when we come here, we're going to say that I can't start by loading this. You see, I must load the contents. You remember, you start with the brackets always. So I load what's inside. I must load into register 1I. So now I'm still here. All right, now I load into register 1I. So I'm loading here into register 1I. Then after loading, I must multiply by, remember, A and B are arrays with 4 byte elements. You see, right? So when you multiply A with this, you must multiply with it. You must multiply with it in the form of an array. It's like remember when we were storing, right? Or when you are, let's say, adding 2 contents and you must store into another content. So it's like we're doing something like that. When we multiply, we must have 3 steps. So, or we must have 3 sections. 2 sections of a register, the other section of a byte. So here what we're going to do, we're going to multiply this. We multiply this register. It's I. I'm multiplying I with 4 byte. You see right now, I'm multiplying I with 4 bytes so that I can have this. All right, and I'm multiplying I with 4 byte. So I multiply I with 4 byte. You remember I now is stored in R1, right? Then I store these details into R1 so that I can now have this. That's the only way. This must go with a byte to show that it's an array. You see, right? And then now I'm going to load this into another register now in total. But you're gonna use these brackets instead of the close brackets, right? Because already you have stored the byte. So I load this now into the second register. You see, right? And then I stop there because I know that X is equal to this. So I won't load this here. You see, I won't store this thing into X because X is equal to something else. So I'm not done with X. So Now we see, so here's the thing, right? I can tell you this. Once you're able to compute one line, the other one is simple because you can check here. Check this. It's like you're just copying and only change a register. Use the register 1, register 1, register 1. Then the second one here will be 2. Even here you reuse register 3, 3, 3. This one will be 4. That's right. So let's compute this one and see what we get. First, I need to load this into a register. Already I've used the register 1 and 2, right? I'm loading J into register 3. And then we know that the byte of this is 4. So I'm going to multiply register 3 with 4. Then I store these things still in register 3. You say, right? And then, so that the reason I'm doing that is because I want to have this in the form of B, R, whatever R that I'm dealing with there. So the register is 3. You say, right, ne? So now I store this into a register. In other words, I'm storing all this into a register. I got this one had its own register. Even this whole thing must have its own register. So I store that into a register. Now it's in a register. Now I'm done with this too. We say, right? Then it means that now I can come and store here. Must come and store. We know what this is. This is what? It's it's this, man. It's this. This is this. It's A, R1. And we know what this is. This is A, R3. You see, right? So since we know what these are, and so it means that I can come here and say this. I can say this. I can come here and say this. Let me erase a few of these, right, so that I can have space, so that I can write them in a manner that you're not confused. So let's write them like this here. Remember, this one is stored in what? In register 2. So I'll call this R2. And remember, this is R2. And remember, this is stored in register 4. So I'll call this R4. And we know what this is in detail, right? It's A, R, and this one is AR, it's AR1, right? It's this one, AR1, and this one is AR3. So now the last instruction says that I must store Y into this. You say, right, ne? And Y is this. Y is equal to what? Y is equal to R4. Already I know that Y is equal to R4. You say, right, ne? I know that Y is equal to R4. So I'm going to store now. So let's go store that. So I'm storing this and that. I'm storing Y is equal to R4. So here I'm going to store R4 into AR1. And we know that X is R2. You say, right? So I'm just going to do that. Store there. So we know that it's going to be simple to store. So as long as you know that Y is equal to R4, X is equal to R2. So I'm storing now. I store into AR1, R4. And I store into BR3. And this one is B. BR3, I store R2. You say, right? Then I'll be done for that expression. Do you guys understand here on these ones? Oh, it's a bit tricky. Guys, do you get it? This one is going. I get it was not there in the exam. It's going to be. I thought it was going to be there in the exam, so they didn't bring it. So it means that it's gonna be there in the supplementary. And this one usually it can consist of 5 marks. It's possible because they know that the majority won't get it. We say, right? So since they know that the majority won't get it, they might bring it to be 5 marks, if I'm not mistaken. So if there's no question, let's look at this one. I want you to participate on this one, right? I want us to look at this one. let's do this. Let's look at this one. Let's say now we have let me check on the notes. It's what is it on the notes? I want us to look at this one now, right? On the notes, it's x equals to ai, x equals to ai, and then it's y equals to, this one is bj, right? Or bi also, bi. Is it bi? This is bi. Then the last one is z equals to x times y. Z equals to x times y. This is z equals to x times y. Z equals to x times y. So let's try this, right? So now we want to try this, then we can confirm if our solution is correct. So remember, I said that first thing that you need to do, you need to load the inside into some register. Afterwards, you get this one into its own register. After, I can look, the steps are 3, right? For you to complete this, you must know that you must have 3 lines. First, I loaded this into a register. Then I multiply by a byte. Remember, our byte is 4, right? So we can multiply by a byte. And another thing, it's more preferred that you'll see when I write here, it's more preferred that the byte goes with hash to hash. Even though I didn't write it previously, it's more preferred that it goes with hash. So I'm gonna write it right. So this time. So first we're gonna load. We're going to load. Remember, it's 3 steps, right? It's load, multiply, and then I can say you load. So you must know these are the 3 operators we're gonna be using. So it's load, multiply, load. So I'm computing this now. So I'm loading into R1, I'm loading I. Then when I come to multiplying, I must have 2 registers. You see, right? And I'm multiplying what? The byte. So this time, remember that time I didn't put a hash, but you must put a hash, right? So, and then after here, now I said that the reason why we are doing this one is because we want to change this into what? Into A, R. We stored I into R1, so we'll replace I by R1. Because the compiler won't allow this, or an assembler. If we're gonna, usually this will be used in assembly language, right? It won't allow an array to be computed like that. So we must use something in here. So usually, like this is, if it was in assembler, it would allow it, but since here we're using a compiler, remember, so it might not allow this computation. So we're going to say that this now will be stored into a new register. Remember, when I multiply this, they'll be stored in R1. So this R1 must be stored in R2. Now remember, so here's what we know: x is equals to this will be, it's gonna be R2. Since this A1, it's x, is this whole thing, so x will be R2, which is this. Then now let's do the one of y. Then I was still gonna do the same thing, right? We load, multiply, load. So already I know the syntax, right? I've already used R2, so now I'm gonna use R3, hash 4. You see, right? So, but check this. Here, I'm using the same variable, so there's no need for me to come and do this, right? There's no need for me to come and do this too, because I'm using the same variable. You see, right? If I was not using the same variable, there would be a need. So there's no need for me to come and do this because I'm using the same variable. So it means that I can also do this. I can say this or let me just use this then, and then I'll optimize it after, and then I'll tell you what you're supposed to do. So we know the syntax say this for y also I was going to say this, then I say R4 here, then I say B R3. But remember, this is saying BI, and already I we know it's R1. You see, so it means that we can get rid of this line. There's no need for this line. This line is just gonna give. Remember, we are trying to minimize the cost here. That's just I had to start with the cost. So we are trying to minimize the cost. So we must try to eliminate as much lines as we can. And since R1 is equal to R3, I'm also gonna eliminate this. You see right now? I'm also going to eliminate that. Then R3, I'll replace it by R1. So now I optimized the code. You see right? So that, because I don't want you to cram, I want you to know why this time am I not going all through the 3 steps. You see, now I'm just gonna do this. And I can't use R4, I must reduce it to R3 because I haven't used R3, right? So I want us to move in a yeah. So now this will be it, R1, R2, R3. So I stored this in R3. So now we know that Y will be equal to R3. So we know that. Now we come here to Z. So I can't store this into X, right? I can't store these 2 into X. I can't store R2 and R3 into X. The reason being is because X and Y are still being used somewhere. Yes, right? So I can't store them. Now I must come here somewhere and do something. So when I come here, right? When I come here, remember, and another thing, let me see if I think I've done this. So I can't store these ones, right? X and Y. So I must do something else because I can't store those, right? I'm sure we agree with that. So now I'm going to say this. So now I can say here that since I've already loaded BR1 into R3, I must come to this one and start to apply what I see there. What I see here is multiplication. I must multiply this and this. Yeah, this is R3. R3. So I must multiply X and Y, right? So I'm going to say multiply. And what comes first? Whatever that came first is X, right? So X is R2. So I'm going to store whatever that I'll be doing into R2. So I'm multiplying R2 and R3. We say, right? Multiplying R2 and R3. And then what I can say here, I can say that after multiplying them, I can store them into Z now. Now I can store them into Z. Now I'm storing this into Z. R2 into Z. We say right now. So now let's check if we can optimize further. It's possible that we might be able to optimize. So now let's check. We stored into R1, we stored I, and then we multiplied by that byte. Then we stored it into R. Then we loaded the content of this into R2, right? Then another thing, guys, R1 from here can also be reused, right? Because now I've loaded the content of this into R2. So R1 can also be used. You're allowed here to come and say, I'll use R1 again. You're allowed to say, I'll use R1 again for this one. Because R1, once I store the content of R1 into this, I can use R1. There's no need for me to hold R1 to have something inside. I can still reuse R1. So it means that I can even come here and optimize this code to say this can be possible that I can change this R3 into R1. But you only do this when you are working with these ones of let me see, that was X, and this will be 1. These ones I stored them in what? I stored into R1, and then R1 is Y. So this I can also optimize it further to say R1. So now let's see, I multiply this 2, this much. Okay, let me check, this pen is, let me try to plug this pen out right now. Yeah, so yeah, I think now it won't turn off. Yeah, so we say that now, since remember here I loaded the quantity of this, right, into R2 of X into R2, right? Then I loaded the contents of Y into R1. So here it means that I can go like this and say that this is gonna be X comes first, right? So I can say this logic, say I'm gonna multiply R1 with R2, and then I store this into R2. Then I'm gonna have to have this, right? At the end I store all this into Z. So also when it comes to optimizing this code, right, sometimes it can be tricky, right? That you'll find that sometimes someone uses here, decides to store all this into R1. That's still correct. You can store this into any of these, right? So, but I'm just doing this because I want us to always get used to storing to the one that comes first. So here we can store into N, we can store into X, we store into Y. You see, so you can store here into N of these. So you see here, I decided to store into R2. Then if I decide to store into R1, it means that the code will only differ from here. But a register is just a register, right? It means that I was going to say R1, R2, R1, right? So when it comes to store here, I was going to say this, R1, you say, right? So that the code can be like this. But I believe that they're gonna bring this. So they'll bring this, they'll be there. That's what I believe, that they'll bring them. So yeah, now if you have any question you can ask, right? Then let's see what we have there. Let's see what we have on the slides. So what was what? Yeah, you see even here what I had used, right? I had decided to store this. They only differ here, right? I had decided to store this into R1 instead of R2, you see. So when it comes here, you can decide whether I get X was R1, this was X was not R1, right? Let me see. X was R1, then I multiply by the contents, then this is X was R2, X was R2, and then Y is R1. Yeah, so we see this. So Y is R1. So we could do this, right? We could decide. Or for you to know how can I write it like this, you can try to optimize until the last code. You just write until the last code. So we can even do that, right? Let's see if we write until the last code, because I want us to make sure that we get, we're only gonna write it down here. Let me erase it. Then we'll write all the code. Then we'll optimize at the end. We can do that. Then let's say first I load. Again, I want to do this one, right? So I'm gonna do the three things: load, multiply, load. Then I want to do this one. I do the same thing: load, load, multiply, load. Right? Then if I want to do this one, I'll multiply the two. I multiply. I must have two registers, right? And Z. So I must, let me see. Yeah, I must multiply X and Y and store them in some register. Then lastly, I store into Z. I'll store that one register that will be there. So let's start here. I'm loading I, right, into R1. I load I. into R1. Then I multiply. When I multiply, I'm going to have both R's, right? R1 hash 4, multiplying by the byte. Then I loaded this into R2. I'm loading A, R1. This one, right? And then I do the one for B now. Let's do it. It's R3, I. So we're going to associate them at the end, right? Then this is going to be R3, hash 4. Then I load into R4, A, R3. We say, right? Then now when you come to multiplying, I want to multiply. Remember here X is R2, Y is R4 in this case, right? I want to multiply and R2 comes first. I want to multiply this, multiplying R2 with R4. Then I take the contents of R2, I put them there. So now let's try to optimize this code and see what we get. So optimizing this code, I'm going to start here. Right, I say that we see that these two, we are storing I in both of them, right? So it means that I can replace R3 by R1. So I remove this. Yeah, I think I have to reduce this line. I remove this. Wherever I see R3, I put R1. Then I'll check what else is the same. Also remove this. Wherever I see R3, I put R1. Wherever I see R3, I put R1. Wherever I see R3, I put R1. Yeah, and then let me move this up here so I can see. Yeah, so we realize that here we can't use R4, right? We must use R3. You see, because R3 was the next one, and we remember that R3 is the same as R1, so I'm forced to even change this R3 to R1. So remember, let me re-explain this again. Again, now we removed R3, right? We replaced R3 by R1, and we realize that I can't move from here. The registers that I've only used here is R1 and R2. I can't move from R2 to R4. It's impossible. I must move from R2 to R3. So it means that this R4 is bound to change to R3. And R3 is the same as R1. So even this R3 will change to R1. You see right now? So this will be R1. So wherever I see R4, I'll change it to R1. R4, I'll change it to R1. Right? And then, let's see. Yeah. And then, you see, this could also lead us to what? To having R2, the one which we had initially. You see, right? You remember initially we had R2. So this could also lead us to R2. But I said that you could also do what? You could also use R1 here. You're still fine. So you could also store this in R1. So I'm sure that this still confirms our R2, right? But you could still use R1 between these two. So, because multiplication commutes, you see, right? So in other words, we can be able to use between R2, unless if this was negative, right? Unless if this was negative. But since it's multiplication, even if I say y times x, it will still give me the same solution. So here I could still use R1. We see, right? So the answer is the same. So now let's look at the other one. So the other one that we have now here, we have this one. We are saying x, but I can even do it like this, right? I want to compute this, so I'm gonna put 3 statements. Remember, load, multiply, load. And then I load into R1I, right? I load into R1I, then I multiply by that you multiply by that byte, which is 4. Right, I said that you can put a hash here. Just that when I was busy writing the code, it's difficult to also put hash. It's like a hash means something else in that compiler. So I just wrote 4. So now let's come here. We know that here first I load this I into that, then I multiply by the content so that I can have this type of expression, right? Then I take this expression, load it into R2. Now I'm done here, right? X is, let's see if A or X is found here. So I can't store these things into X. So X still need to be used. So, and X is what? Let's see, what is X here? X is R2. X is also R2. So it means that this now, Y is equals to B R2, because X is R2. So it means that now I must load this into a register. Is that right? Remember last time when I said that you could, here I would choose 3, right? You would be fine if you choose 3, right? I would choose 3. But this register, when it comes inside here, it's used already, see? So I could still use it again. So I could still use it here because I've already used this register. So I can use it here to come and say that I could load this into R2. I hope we say this right. I could load this into R2. Then I take this R2, load it into this. But let's follow the code and see if we're going to get there. So let's assume first that I had decided to use R3 here. I load this, which is this, into R3. Yeah, I'm loading all this thing into R3. It means that this now will be equals to R3. This Y will be equals to R3, right? Then I'm loading that into R3. Then this would change to R3 because that's Y. Then this is that I must store this Y. Y is R3 now, right? And this one, AI, we know that this one, AI, it's this one. It's AR1. Now it says that I must store R3 into AR1. So I'm going to store this R3 into R1. So I said that since R2 was used, we could still decide to say I'm going to use R2 there. Remember, it's the same thing with the one which we just did previously. Here we had what? We had R2. Then I said that since this R1 was used, and now since it was used here, right? It means that it can be used now. We can take that because it's no longer useful. You see, right? This was used. When we come next, we can come and say, I could store these things into R1, or I could store them in R2. It's up to you. You could, when you multiply these two, you can store them in R1 or in R2, right? So we could store them in any of these. Then we choose R1. And then even here, instead of choosing R3, we decided to say that since this, again we see we multiply this two, right? Then we store in R2. Then we come and use that R2. You see, we say that now instead of having R2, we're gonna have B R2. It means that I can even store this into or load this into R2. You see, right? So it's like I'm multiplying B and R2, then I store the contents of that into R2, like what we are doing here. So this is what I would advise. So I would advise this case. Yeah, I would advise this case. Yeah, I think you guys didn't do pointers, right? I don't think you guys did pointers, but they are more or less the same. So they're not that difficult. So you can also look at them. So any question, guys? Yeah, I think we can stop here for now. Then the next section we're gonna be doing. I'm still preparing the slides for the 3 address codes, the triple, quadruple, and those ones, and also the indirect triple sequence. So I'm still preparing those so we can do that. So also we can also do this. These ones can also be written in the form of a 3-address code, the quadruple and triple. So we should be able to know how to write those, because anything is possible in a supplementary, right? So we must be able to write them. Yeah, then we can call it a day, guys. For today we can stop here.